To do is keep your eye on this and tell me when it's full.
Well, I don't know that I'm going to know, but I'm guessing that it's pretty soon. How about now?
Right now.
Okay.
Good call.
Excellent guess is what that was.
Okay. Now,
what do you do here?
Propane, heavier than air. We're going to light the top of this tube right here.
Right.
Won't ignite.
Yeah, nothing.
However,
nothing. Not a flash. Nothing. Wow. Okay.
We can ignite it down below.
It's at the bottom, then it kind of pools down
Heavier
here,
than air.
so it could be here and coming down or whatever.
Exactly.
Okay.
Now, let me show you the pooling effect of the fuel.
Oh.
We can actually pour the fuel in here.
We can't see a thing, but it's happening, huh? Look at that.
Okay.
So that flamed right up. Obviously, it had pooled down here. When you poured it in, it followed your motion.
Exactly.
Oh, okay.
Okay, Dale, you just saw the demo on propane being heavier than air. What I'd like to do is demonstrate for you how natural gas is lighter than air.
Oh, I'd like to see that.
Let's turn this off, the flame off here.
Okay.
Okay. And what we're going to do is we're going to fill this tube with natural gas.
And being
now,
lighter than air, it's just going to
come right up
displace the air in there.
Now, I know that you weren't able to quite see the propane when I was pouring it in the tube. My question is, can you see the natural gas?
Oh, it's much clearer. And I literally mean clearer. I can't see it.
Okay, I think we have enough in there.
Okay.
Okay.
Nothing at the bottom.
Nothing at the bottom, which means that it's not dropping. It's lighter than air.
Okay. But there it is. A nice blue flame at the top. That's interesting. That's interesting.
Okay.
Yeah, there it is.
And now what we'll do, Dale, is we'll release the gas. It quickly diffuses in the air. Can you see it coming out?
Yes, I can. I can't.
And it's completely gone.
That just dissipated right into the atmosphere.
Very quickly.
Okay. That is a lot safer than the other gases.
Exactly. That's one of the safety features of natural gas as compared to other fuels.
I've heard of something called the limits of flammability. What's that?
Well, Dale, you need three things to achieve combustion.
Oh, okay. What are they?
You need fuel in a gaseous state, air, and a source of ignition. Now, in the case of natural gas, obviously it's already in a gaseous state.
Right.
However, one important note to remember is that you need the right mixture of natural gas mixed with air in order for it to burn. For natural gas, the range is 4 to 14%. For propane, 2.4 to 9.5%. And for butane gas, it's 1.8 to 8.4%. Ether is as low as 1.9 to 4.8%. So again, a safety feature of natural gas, it's its higher limits of flammability.
Okay. Can you show me how that works?
You bet.
Okay. What do we got here?
What we're going to do here in this long glass tube, we're going to fill it with natural gas.
I can hear it. Yeah.
And in essence, what we're going to do is we're going to saturate the tube with natural gas. We're going to exceed the 14% limit.
Okay. More gas within the oxygen and other elements in air.
Absolutely.
Okay.
So it's going to burn up here at the top where it can readily mix with the oxygen, but it will not burn inside the tube.
But not in the tube.
Absolutely.
Okay. So it's only burning up off the top there.
At the top.
I can see that. It's blue. Yeah.
The mixture inside the tube is too rich, way over 14%.
Oh, okay. Okay. So like a carburetor.
Just like a carburetor, exactly.
Okay. Yeah.
Now, what I want to demonstrate for you, and this is a neat little feature here of this experiment, is we're going to make this flame burn up here, from up here, all the way down inside the tube.
Why is it going to do that now?
Well, because I'm going to introduce some air inside the tube.
Okay. To get it within that 4 to 14% range.
Yeah, exactly.
Okay. I got it.
Now, as I continue to add air to the mixture in here.
So it's getting more oxygen.
More oxygen.
Okay.
So the gas and the oxygen are beginning to mix inside the tube.
Adds it, and then the flame will come racing down. The inside part here is the mantle, isn't it? Well, look at that. That's pretty cool.
Now, the tube is within the 4 to 14% range.
Because it's burning inside. You can see the flame leaping all the way up.
Now, I'm going to continue to add a little
marshmallows.
A little bit more air inside the tube, and we're going to make the mixture a little bit too lean.
So too much air there, huh?
Too much air.
Oh, I see. So it won't light in there at all now. It's a visual thing, isn't it?
It's a visual thing. That's how we demonstrate the limits of flammability. Again, if the gas is not within the right mixture, 4 to 14%, as we've demonstrated here, it won't burn. Again, one of the other safety features for natural gas, it's the high ignition temperature it requires for it to ignite.
Okay.
Minimum 1,200 degrees.
That's a lot.
That is quite a bit. Let's compare that to other fuels. For propane, as little as 950 degrees will
Okay.
ignite it. For butane, 900 degrees will ignite it,
Mm.
which means that a cigarette can ignite butane.
Oh, okay.
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 For ether, as little as 356 degrees will ignite ether.
That's almost anything then. Just
That's
an open
anything.
flame of any kind or whatever. Would
That's
that send it, you think?
well, baked cookies in the oven.
Is
If
that
you were to
right?
put a container of ether in there at 350 degrees,
That would do
it
it.
would ignite.
Oh, okay.
Very volatile.
So 1,200 degrees. That's a spark or above. Probably.
That's a spark. That's an open flame.
Oh, okay.
But it has to be hot enough.
Okay.
Well, we've had this burning here for quite a bit, and what we have here is a piece of carbon steel,
Right.
and as you can see, it's glowing cherry red.
Uh-huh.
Okay. Now, glowing cherry red, you think it's hot enough to ignite natural gas?
You would think so.
You
sure.
would think so.
Yeah.
Well, let me demonstrate something for you. I'm going to turn off the fuel supply to that burner,
Okay.
and then reintroduce the fuel supply again.
Okay.
Now,
No flame.
gas is not igniting. Okay. However, that steel is hot enough to ignite this match.
So it wasn't 1,200 degrees.
It wasn't 1,200 degrees,
But the match is.
but the match
Oh,
is.
okay. Okay.
So,
So that is a good safety feature. If it's something that hot cannot ignite natural gas, I think that's a great safety feature. Had that been butane, it would have.
we're pretty sure that it would have ignited it.
Okay.
Yes.
Okay. I can see what that is.
Okay. Now, from the demonstrations that you've seen here, Dale, it's safe to say that natural gas, when treated with respect, is a very safe fuel.